Dear students, good morning. Today we are going to see the next topic from third unit, that is spatial filtering. So before going to enter into the topic, first we can see what are the things we are going to see in this topic. So starting, we are going to see what is spatial filtering, what is the use of spatial filtering, and what are the types of spatial filter, and how the working of spatial filter, and example of spatial filter operation. So like that, we are going to discuss about what is spatial filtering and associated topics. So first we can see what is spatial filtering. So to understand about what is spatial filtering, first we want to know what is spatial and what is filtering. So spatial, if you want to define this, it is a relating or specifying a location or refers to a particular space. So that we can be say refer it as spatial. Then corresponding to filtering can be defined as allowing or rejecting certain frequency components, that we call it as filtering. So commonly we can define what is spatial filter. So saying about spatial filter, the device that suppresses certain frequencies in image pixel to create specific changes. So that we can call it as a spatial filter. So I think now we got an idea what is spatial filtering. That is making some changes in a particular pixel in a particular location. That we can call it as spatial filtering. So what are the uses of spatial filter? So the main advantage and use of spatial filter is performing operations directly on the pixel of the image. So that is its speciality. That is its use. So the generally, what are the operations that are carried out using spatial filter? So we are having a very major applications, that is one is smoothening in the part of smoothening, and another one is sharpening. So saying about smoothening, it is carried out with the help of low pass spatial filter. So this is carried out to reduce noise, to avoid aliasing effect. So for this purpose, we are using this low pass spatial filter. So next we can see about sharpening. Here it is carried out with the help of high pass spatial filter. The functionalities which is carried out are removal of blurring and highlighting the edges. So for this purpose we are using this spatial filter. So next we can see about its types. So there are two types. One is linear spatial filter and another one is non-linear spatial filter. So we know that spatial filtering modifies an image by replacing the value of each pixel by a function. So if the operation is performed on the image pixel is linear, then the filter can call it as linear spatial filter. So or if otherwise, if the filter is non-linear, then the filter can be referred as non-linear spatial filter. So like that we are having two types of filters, that is linear spatial filter and another one is non-linear spatial filter. Now we can see how the spatial filter is working. So now we can have an example. So saying about spatial filter, filter performs the function of sum of products. So it is sum of products between an image and a filter window. So what is the operation here? It is carried out. The operation we are carrying out is, that is, it performs sum of products between image and filter window. So saying about this filter window is an array whose coefficients determine the nature of the window. So the coefficients represent whether it is a linear filter, non-linear filter, whether it is a low pass filter or whether it is a high pass filter. So like this, the window coefficients represents the nature. So the window filter window can be referred in different names like this: filter mask, filter template, filter kernel. So this operation, this sum of products is carried out in two ways. Either it is carried out by correlation or by convolution. So either by correlation or by convolution. So the if you want to say about the difference between them, correlation is directly we will be carrying out the sum of products, and whereas in convolution, after carrying out 180-degree phase shift, we will be carrying out the sum of product operations. So this is the major difference. So this is the image array, and this be the window array. So the combination, the sum of product between them carried out using with the help of correlation and convolution gives the result. So which is detailed with an illustration in an example. So saying how the operation is carried out, that is between moving the center of a window over an image and computing the sum of products at each location. So in case if the values of a windows are symmetric about its center, then the correlation and convolution yield the same result. So I think we can see in this the illustration. So this is the pixel values of image, and this is the window the values of the coefficients of window. This is the coefficients of image, and this is the coefficients of window. Now we are carrying out the filtering the image with the help of the filter window. So the operation is carried out. The operation can be carried out either correlation or using convolution. In correlation, the window is directly, the sum of product is directly carried out, and we will be getting the result like this. When saying about convolution, here the filter window is 180-degree phase shifted or rotated, and it is again the sum of product is carried out, and we will get the results. So this can be linearly represented in like this way. It can be linearly illustrated. So and the same thing they are saying about correlation. Here this is the image pixel values, and this is the window pixel values. In correlation, we are directly carrying out the sum of products, and in convolution, we are carrying out 180-degree rotation, and after that we are carrying out the sum of the products, and we are getting the results. So like this, the spatial filter is used for smoothing and sharpening in various applications with the help of this correlation and convolution. So I think now we got an idea about what is spatial filtering, its uses, its types, its working, and we have seen some examples also. So I think with this I am going to wind up this session. For reference, you can prefer these textbooks and reference books, and further for any clarifications, you can contact my WhatsApp number, that is 9710260926. Thank you.